So this is the last section in chapter 4. Triangles and coordinate proof. We've done this before. Who was that just came in?
I have no idea.
Yeah, it's just
Was she wearing a dress?
Yeah.
Well, then your choices are
Okay, coordinate proofs. This is stuff that we've done before, just never in this type of form. They tell us you have a right triangle that has legs of 9 and 12 units. Now, you did this back in 8th grade, just a little bit last year. A right triangle, if you drew it, and it says the legs are 9 and 12. So they're wondering, find the length of the hypotenuse. So you're looking for that. Remember in a right triangle, the theorem that you can find, if you know two sides, you can find the third? Starts with a P. Pythagorean theorem. A squared plus B squared equals C squared.
Yeah.
So all we'd have to do is take 12 squared plus 9 squared, and then to get the C by itself, you got to square root it. Remember doing that? If it's the hypotenuse you're looking for, you square them and add them up and then square root it. If it's a leg we're looking for, we would go 12 squared minus the leg squared and square root it. Take the hypotenuse minus that. We're not doing that today, but. So anyway, this one is in geometry. We're going to do it on a coordinate system. So it's maybe a little hard to see, but here is the y-axis and here's the x-axis. And then they drew a triangle in here. Right there. This is 12 over 0 up, so this leg is 12. Then they went up 9, so this is the coordinate 12 over 9 up. And then this vertex is over in the corner, 0, 0. Now when you put these on there, you can put them wherever you want. You could draw your triangle like this, 12, 9, and then connected. It can be anywhere on the coordinate system you want. Instead of putting it down like that, I could have went like this. I could have went up 9 over 12 and then drawn it. It doesn't matter where you put it. And that's what we're doing today, is they're going to tell you to draw either a triangle or a square or a rectangle. You can put it anywhere you want, but to make it easiest, you want the one point to be at 0, 0. Again, you don't have to, it just makes it a lot easier if you do. So the reason why now is in order to find the length of the hypotenuse, which is this, we did this back in chapter 1, we used the distance formula to find the length of a segment. Distance is x minus x squared plus y minus y squared, and then you got to square root it. So the reason why it works nice if you got 0, 0, when I take this x, remember x is the first term, minus this x, 12 minus 0 is 12. It's just easy to do in your head when you've got 0, 0. So that's 12 squared plus the y minus the y, 9 take away 0 is 9 squared, and then you square root it. And it turns out to be 15. Now if you notice, the distance formula is exactly the same thing as the Pythagorean theorem. Same exact thing. It's just on the distance formula, when you subtract the x's, that tells you how long this leg is. And when you subtract the y's, it tells you how long that leg is. So, again, you're either going to have to draw in triangles or squares or rectangles. On graph paper, I'll give it to you. Here it says you got a right triangle. So you need to make an axis. And most of our stuff we'll just do in the top right, so the first quadrant. So you can just make an axis like that. The legs are 7.5 and 4. Now, since it only goes up so far, I would go out 7.5, which is actually right to there, because this is 7 right there, and then up 4, and then come down here to get the right triangle. So this is 0, 0, and this is 7.5 over and 4 up. So what they want you to do is find the length of the hypotenuse, right there, using the distance formula. So we would have to take 7.5 take away 0, which is 7.5, squared, plus 4 take away 0, 4 squared, square root it, and I think that one is 8.5. Yep. Now, a couple of the questions tell you to draw in a rectangle. That has, say, sides of 5 and 7. So it doesn't matter which way you go with it. I could go out 7 and up 5 or out 5 and up 7. Doesn't matter. When you put it on there, if I went out 5, this would be 5, 0. This would be 5, 7. This would be 0, 5, or 0, 7. What they want you to do on these rectangles is find the length of the diagonal. Doesn't matter which diagonal, just length of a diagonal. So this turns out to be exactly the same as these. Because once you draw your rectangle in there and you draw the diagonal, what does this make? A right triangle. So all you got to do is use the distance formula to find the distance from here to here. Okay? So you will need the distance formula for your assignment. And the midpoint formula, which we also did in chapter 1. So a midpoint is just a coordinate. It's the x's added together divided by 2, the y's added together divided by 2. So in this picture, they tell us WXZ, which is this triangle right here, is congruent to YXZ. They want you to find the coordinates of point Z. Now, if it's a really good graph, which this one is, you don't need to use the midpoint formula, you can just figure it out. These go by tens, Z is right here, so it's over 10, 20, 30, and it's up 10, 20, 30. So point Z is at 30, 30. But if it's not a good graph, you use the midpoint formula, because since these are congruent, that would mean all the corresponding parts are congruent. Like this side equals this is a shared side, and these sides are equal, right? Since this equals that, Z is the midpoint. So all I'd have to do is take the x plus the x, we're doing the midpoint, 60 plus 0 divided by 2 is 30, and the y plus the y, 60 plus 0 divided by 2 is 30. This one is not as easy to see. So you'd want to use the midpoint. Same thing, this triangle DEG is congruent to this triangle DFG, which means this piece equals that, which means G is the midpoint. So to find the midpoint, you just take the x plus the x, and then don't forget you gotta divide by 2. Negative 5 divided by 2 is negative 2.5. And it's a coordinate now, so make sure you put the parentheses to show it's a coordinate. Then the y plus the y, 5 plus 0, divided by 2 is 2.5. So there's point G. Left 2.5, up 2.5. Then we get into some of the coordinate proofs. Now this is, it's kind of easier, but it's confusing because they don't use any numbers. In order to prove in this picture, they've got the F, G, J, and H, but they don't have numbers. They just say this is P, T. We don't know what P and T is. This is ST. So they went up the same height. This one is PR. They went over the same and then down. And this one is SR. They went over the same and down. So to prove that FGH is congruent to JHG, you gotta figure out, is it SSS, SAS, ASA, so on. Now, since it's on a coordinate, we're doing lengths, distance, so we're going to want to do SSS. This has a shared side right there. So what you have to do is show that these two are equal and that these two are equal. So, the way you do that is you use the distance formula. And you won't get numbers for your answers. It's going to have letters in it, but as long as they end up being the same letters, then they're equal. So when you do this distance formula, x take away x, p take away s squared, plus y take away y, t take away t squared, and then you square root it. Well, what is t minus t? 0. So 0 squared is nothing. So you're left with the square root of p minus s squared. What happens when you got a square root over something that's squared? They cancel each other. So you're just left with p minus s. So that length is p minus s. Now you got to check to make sure this bottom here is also p minus s. So you do the same thing. X minus x, p minus s squared plus y minus y, r minus r squared, and then you square root it. Same thing, r minus r is 0, so 0 squared is nothing. The square root of a square cancels, so this also turns out to be p minus s. So we just proved that these two are equal to each other because they're both p minus s, the same. Then you got to do this side. So you'd have to go x minus x, p take away p squared, plus y minus y, t minus r squared, and you square root it. P minus p is 0, which means that's nothing. Square root of a square cancels, so this is t minus r. Then you do the same thing on this side to see if you get t minus r. X take away x, s minus s squared, plus t minus r squared, square root it. S minus s is 0, that cancels. So the square root of a square cancels, and you're left with this side is t minus r. So there we showed that these sides are equal, these sides are equal. So they're congruent because of side, side, side. Okay? Now, on your assignment, We don't have to do any of these with the letters in. The only reason I showed it to you is when you take your MCA test next year and your ACT, they have some of these problems like this. And you will see this again next year in Algebra 2, so it's not like we won't see it anymore. But so, on our assignment, we won't do this. We're just going to do the midpoint ones and where you got to draw the triangle or the rectangle ones. Okay? So I'll give you graph paper to do that on.